Here we're asked to find the solution to the following equation for angles restricted to the interval 0 to 2 pi. The first thing we should try to do is think about how we can solve this equation. And we don't want to reinvent the wheel here, so let's use some of our algebra techniques. Both the first and second term have a shared sign factor, so let's factor that out. So we factor out a sign from the first term, we're left with 2 cosine x. Factor out a sign from the second term, we're left with a minus 1. Now because the product of these two numbers has to be 0, that means that sine x equals 0, or 2 cosine x minus 1 equals 0, which means that cosine x equals a half. Now we're going to search for solutions between 0 and 2 pi for both these two equations. So let's start with sine of x equals 0. Now if you think about the graph of the sine of x, there's a lot of places the sine of x equals 0. At the origin, at pi, at 2 pi, at negative pi. In fact, any integer multiple of pi, the sine of x will equal 0. However, we're only looking for the angles between 0 and 2 pi, so here x will just be 0 and pi. And we don't include 2 pi because this interval does not include 2 pi in its definition. We don't have a square bracket around the 2 pi. For the cosine x equals 1/2, I think a unit circle helps us figure out what the correct angles are here. So if we draw a circle with radius 1, centered at the origin, and remember that the cosine of any angle on this unit circle is the x-coordinate of the point that intersects the unit circle. So when x-coordinate is 1/2, we have two possible angles here. And this is a pi over 3 angle, which makes this negative pi over 3. So the two angles we're looking for as solutions to cosine x equals 1/2 on the interval 0 to 2 pi would be pi over 3. And then almost 2 pi, but minus pi over 3, so 5 pi over 3. So those are the four solutions to this equation: 0, pi, pi over 3, and 5 pi over 3.